Hello and welcome to Term 3 Natural Science. And for this term, we are going to be focusing on energy and change. Okay, for this term, we are focusing on energy and change. Okay, and under this section, we will cover 4 units, and that will be the end of the term. Only 4 units. The first unit is static electricity. The second unit is energy transfer in electrical systems. The third unit is electrical circuits. And the last unit, which is unit number 4, is the visible light. Okay. And we start with unit number 1 that covers static electricity. Static means something that is stationary, something that is not moving. Okay. And under static electricity, we'll look static electricity is divided into 4 sections, which is 1, friction, 2, its forces between the charges, and number 3 is polarization, and the last one is safety. All of these 4 will fall under unit number 1, which covers static electricity. Okay, this is in page 165 of your textbook. 165 of your textbook. Okay, so let's start from the top. They say, have you ever experienced the following? The tiny shocks when you touch a door handle, like it goes click and you are getting a little bit shocked. Small sparks when you take off a jersey in dry weather. And they say these are caused by static electricity. Okay, so let's start with number 1. When two neutral materials, remember when we were doing elements, okay, so we learned about positive charged and negatively charged and neutral elements. When two neutral materials, both having equal numbers of protons and electrons. This is very important. A neutral material or object will have equal numbers of protons and electrons. For example, there will be 2 electrons, there will be 2 protons. Okay, therefore there is no difference, and the matter or the object will be neutral. Okay, it can be 16 electrons, 16 protons, and the object will be neutral. As long as there is equal numbers of protons and electrons, the object is neutral. So here they say when two neutral materials are rubbed against each other, friction, when you rub materials against each other, you cause friction. Some of the electrons move from one material to another. So the electrons, remember, electrons are the negatively charged ones. So if you rub 2 materials against each other, some electrons will move from one material to the other. The result is that the first material now has fewer electrons than protons, which means the protons are many. Therefore, it will have a positive charge. Okay. Few electrons means you will have a positive charge. Let's start again. Neutral material will have equal numbers of protons and electrons. And then positively charged material will have more protons than electrons. Okay, so I will have 10 protons and 9 electrons, for example. Then it will be positively charged because I have more protons. The second material now has more electrons because it has gained electrons. So now it means the material will be negatively charged because it has got more electrons. Frictions between certain materials, for example, plastic, perspex, glass, nylon, wool, and silk, causes electrons to be transferred between the atoms of the materials. Only electrons can move. Very important. Protons, they don't move. It's electrons that move. So positive and negative charges are defined in terms of the balance of electrons and protons. So positively charged, it means it has got few electrons, okay, few electrons. And then negatively charged, it means there is more electrons than protons, okay. Please understand this. Electricity generated by friction is called static electricity. So the electricity that is generated by friction is called static electricity. Please know this. This is because electricity does not move. Remember, I said static means stationary or not moving. This is because electricity does not move, but it is static. Okay. Now we are at the top of page 166. They say friction or rubbing causes static electricity. We have already covered this. And they say static electricity. Now this is the definition that you need to know. Static electricity or electrostatics. What it is the buildup of electrical charge in an object without a flow of charge. Static electricity is the buildup of electrical charge in an object without a flow of charge. You need to know this definition. Let's repeat again. Static electricity is the buildup of electrical charge in an object without a flow of charge. Now let's look at section number 2 under static electricity, and we look at forces between the charges. When you wrap your hand over two separate strips of plastic, electrons from your hand transfer to the plastic. If you hold the two strips close to each other, they repel each other because they are both negatively charged. Why are they negatively charged? Let's repeat this again. When you wrap your hand over two separate strips of plastics, electrons from your hand transfer to the plastic, which means now both the plastic strips will have more electrons, and if it has got more electrons, they will be negatively charged. Now, if you hold the two strips close to each other, they will repel each other because they are both negatively charged. And similar, like charges repel. When you bring your hand close to the plastic, it moves towards your hand and clings to your hand because your hand has a positive charge and the plastic has a negative charge, and opposite charges attract. Now we can deduce this and say like charges repel each other. So the material with the same charge, if they are both negative, they repel, they push each other. Okay, or if they are both positive or if they are both negative, they will push each other. And unlike charges attract, so if I have positive charge material and the negative charge material, they will come into contact with each other. Okay, they will attract. So very important, like charges repel and unlike charges attract. As soon as charged objects touch each other or a neutral object, electrons move from one object to the other until their charges are exactly the same. Now we look at section 3 of static electricity that covers polarization. When a negatively charged object is held near a neutral object, now we have a negatively charged object, which means it has got more electrons, is held near a neutral object. The electrons in the neutral object will be repelled and they will move far aside of the neutral object. Okay, so it's more negative and it's next to the neutral. So the electrons in the neutral object, they will move far aside of the neutral object. The neutral object has now a positive side and a negative side, because the negative electrons, the electrons will move far and the protons will stay. So the neutral object will have a positive and a negative side. The side nearest to the negative object has a shortage of electron, and the far side has the excess of electron. The one with excess of electron is negative, and the one with shortage of electron, it will be positive. The negative object and the positive side of the neutral object now attract each other because they are unlike charges. And under the quick facts, when charged object is held near a neutral object, the neutral object gained a positive and negative side. This is known as electrical polarization. You need to know the definition of polarization. Polarization is when a charged object is held near a neutral object. The neutral object gains a positive and a negative side. We are now going to see if we can charge an object in a practical way, and that if that charged object can attract uncharged objects. So this is a simple practical that you know, and maybe you've done it in your previous grades. And what is the aim of the investigation is to investigate forces between charged and neutral objects. And then we'll have a plastic ruler, we'll have a silk scarf, and we'll have small pieces of paper. And then you must rub the ruler with the silk article and bring the ruler close to the particles, and you must say what happens. Okay, so let's watch a short clip and see what happens. Okay, just a short clip to see what happens. There we are. Let me play this. I'll take it back a little bit. So that happened in that investigation. Okay, let's look at the explanation now. Initially, the ruler and the scarf are both neutral. In this case, they use another piece tissue paper are both neutral. So the ruler and the tissue paper are both neutral. In both cases, the number of positive protons and the negative electrons are equal. When the ruler is rubbed with the scarf, the electrons are transferred from the silk or from the tissue to the ruler, and the ruler now has an excess of electrons, which means the ruler is negatively charged. The silk has a shortage of electrons, which means it is positively charged. Now, when the negatively charged ruler is held near the pieces of paper, electrons in the paper are repelled to the other side. The side closest to the ruler has a positive charge and is attracted to the ruler. As soon as a piece of paper clings to the ruler, some electrons are transferred from the ruler to the paper until they have the same charge. Now they will repel each other. That is why the pieces of paper will fall out after a while. Okay, so now you understand what happens when you do that investigation. Okay, page 168. Let's look at the interesting facts there. This table is very important. Please, this table is important. You need to know it. Okay, let's see. I need to minimize it a bit. They say the triboelectric series was composed to indicate how tightly different materials hold on to their electrons. Okay, this is the triboelectric series. Okay, and it used to indicate how tightly different materials hold onto their electrons. Materials that do not attract their electrons as strongly become positively charged more easily. The list below shows various materials in the order of triboelectric series. If any two materials are rubbed against each other, the material higher on the list will become positively, and the material lower or down will become negative. Okay, so we start from the top. This is the top. So this is very positive. Okay, and this is neutral, and this is very negative. I need to read this again. If any two materials are up against each other, the material on the higher list will become positive. Okay, so which means these materials, they give their electrons easily. Okay, so they will be left positive, and these ones, they don't give they accept the electron easily, so they will get an electron and be more. Okay, so we'll have excess electron and it will be negative. So for example, human hands, we will lose, the hands will lose an electron. Rabbit fur will lose electron. Glass will lose electron. Human hair will lose electron. Nylon, wool, fur, lead, silk, aluminium, paper, cotton, they will lose electron and still is neutral. And wood will gain or will receive the electron. Amber, hard rubber, nickel, copper, bronze, these ones, they will gain an electron and they will be negative. These ones, they will lose electron and they will be positive. So very important to know this triboelectric series. Okay, and then they say that charges that collect on an object are responsible for the shock when you touch a door handle, the sparks when you take off a jersey, especially when the air is dry. The shock or spark occurs when an electrical discharge takes place. And that interesting facts, the Venn graph generator is a piece of apparatus that builds up and operates an electric charge on the dome due to static electricity. And if you hold on to the dome, your hair will stand upright. So go and Google Venn graph generator and see how it works. Just to learn about those interesting facts. Okay, page 169, the last part of a static electricity. They say be careful when filling plastic containers with petrol. The friction can cause a positive charge on the plastic container because the plastic will lose the electron, and the negative charge on the petrol will gain electron and it will be negative. When a discharge occurs, the spark can ignite the petrol as it is extremely flammable. Lightning is also the discharge of electrical energy, one big spark. Stay away from trees in stormy weather, as the tree can be the spot where the discharge takes place, okay, which is the highest point, and you can be shocked. Okay, so that brings us to our first unit on static electricity. So you can complete exercise 15 in page 169. Complete the exercise and you cut and paste the summary in your notebook. You cut and paste the mind map or the flow diagram in your notebook. Okay.